Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 2, Notes 3, and we're going to talk about all different kinds of angles that are formed when you have two lines cut by a transversal. So if we look right up here, it says lines A and B are two parallel lines that are cut by a transversal, T, creating 8 new angles. And the angle pairs are listed below. We're going to talk about the different angle pairs. First, we're going to talk about what it means to be an interior angle versus an exterior angle. So I want you to look at this picture over here on the right, and I want you to see, here's line A, here's line B, and I know they're parallel because they have these extra arrows on them, which means that they're parallel to each other. Now, today we're going to start with talking about interior angles. Interior means inside. And so when I think about these parallel lines, I'm trying to think about which angles are inside of those parallel lines. Well, angle 3, angle 4, angle 5, angle 6, those are in between the two parallel lines. And so those are interior angles. And so an example would be angle 3, angle 4, angle 5, and angle 6. Those are all examples of interior angles. And basically, interior angles are angles that lie between two lines. In this case, two parallel lines. All right, next, let's look at the next picture. So again, we have lines A and B in this second picture down here, and we have the transversal T cutting through. And this time we're going to talk about exterior angles. Now, exterior means on the outside. So we have to think about which angles are on the outside of the two parallel lines. And in this case, angle 1 and 2 are above, and angle 8 and 7 are below. Those are not in between the two lines. They're exterior to the two lines, A and B. So angle 1 is an exterior angle. Angle 2 is an exterior angle. Angle 7 and angle 8 are all exterior angles. And these are angles that lie outside of two lines. So now we know what interior angles are and exterior angles. Let's get more specific. So this next example is an example of consecutive interior angles. So here again, look at our two parallel lines and think about the transversal cutting through. Consecutive interior angles have to be inside the two parallel lines. So like angle 3, but they have to be on the same side of the transversal. So an example would be angle 3 and 6. So for an example, angle 3 and angle 6 are a pair of consecutive interior angles. They're interior because they're between the two parallel lines, and they're consecutive because they're on the same side of the transversal. Let's put that down here. Same side of transversal. Or in other words, same side of line T. They're both on the right side of line T. Now something cool happens when the lines are parallel. Their measure is going to add up to 180 degrees. So angles 3 and 6 together will add up to 180. Another pair of consecutive interior angles, can you look at the picture? There should be one more pair on the left side of the transversal, angle 4 and angle 5. So 4 and 5 together also make a pair of consecutive interior angles. They're both on the left side, the same side of the transversal. Compared to the next term, which is alternate interior angles. So again, here's our lines A and B. Here's our transversal cutting through. Alternate interior angles still have to be interior. So they have to be inside the parallel lines, but they're going to be on alternate sides of the transversal. So take a look at angles 4 and 6. See how 4 is on the left and 6 is on the right of T? Well, angle 4 and angle 6 are a pair of alternate interior angles. They're on alternate sides of the transversal. One's on the left, one's on the right, but they're interior because they're in between the two parallel lines. And their measures are going to be congruent or the same or equal, okay? So I want to write a little note here. They're on opposite sides of the transversal. Opposite sides of the transversal. Now there's one more pair. When you look at the picture, can you find one more pair of alternate interior angles? If you're thinking angles 3 and 5, you're correct. So 3 is here, 5 is here. See how they're inside the two green lines? And they're on alternate sides of the red one. So they're alternate interiors. Next we have same side exterior and alternate exterior. So again, think about your parallel lines. So here's A, here's B, here's your transversal cutting through. We're looking for same side exterior angles. So for instance, if I work with angle 1, that's an exterior angle because it's not between the two green lines. And if I want a same side exterior, I'm going to choose number 8. They're both on the left of T, or the red line. So an example of same side exterior would be angle 1 and angle 8. They would be considered same side exterior angles. Look at their sizes. Do you see how angle 1 looks obtuse? It looks pretty big. And angle 8 looks acute. It looks smaller than 90. Well, their measures will add up to 180 degrees. In other words, they're supplementary. So if angle 1 is 100 degrees, angle 8 would be 80 degrees, so that they would add up to 180. The other pair of same side exteriors, can you guess what they are? Think about angle 2. Angle 2 is an exterior angle. It's above the green line. What's on the same side but below the other green line? 7. So angle 2 and angle 7 are another pair of same side exterior angles. Which brings us to alternate interior angles. So think about your parallel lines. So here's A and B and they're parallel. And then think about your transversal cutting through. And this time we want alternate exterior angles. So alternate exterior angles, think about angle 1. Angle 1 is exterior. It's not in between the green lines, it's above. And what's on the alternate side of the red line, but below the green lines? So 7. 1 and 7 would be a pair of alternate exterior. 1 is on the left of the red line, and 7 is on the right of the red line. So they're on alternate sides. So an example would be angle 1 and angle 7. Now look at their sizes. Does 1 look obtuse to you? It does to me. And 7 also looks obtuse. So guess what? Their measures are going to be congruent or equal, or in other words, the same size. So if angle 1 is 100, then angle 7 will also be 100. Okay? They'll have the same measure. They're on opposite sides. I'm going to write that over here. Opposite sides of the transversal. All right, next, corresponding angles. So think about your parallel lines again. We have A and B, all right? And we have our transversal cutting through. And we need to figure out a pair of corresponding angles. Well, corresponding angles, let's write the definition. They're in angles in similar locations. And what I mean by that is like 1 and 5. So do you see how at this top intersection right here, 1 is above and to the left of that dot? And down here at this lower intersection, 5 is above and to the left of that dot. So angle 1 and angle 5 is an example of corresponding angles. And their measures, if you look at them, don't they both look obtuse? 1 and 5 both look bigger than 90. Their measures will be congruent. Or in other words, they'll be equal or the same measure. If angle 1 is 100 degrees, angle 5 will be 100 degrees. Let's pick another pair. How about like if we go with angle 2? What would be corresponding to angle 2 or in a similar spot? Well, it would be angle 6. So 2 and 6 would be another pair of corresponding angles. Also, we would have even more. We could use angle 3, for instance. So angle 3 and angle 7. I'll just put it over here. Angle 3 and angle 7 is another pair of corresponding angles. They're both in the lower right side. And then finally, we also have angle 4. So also angle 4. And if you're thinking about 4, you should also be thinking about 8. So angle 4 and 8. There's 4 pairs of corresponding angles. So now let's use those ideas to do some of these problems. Everybody take a look at number 1 and look at angles X and 51. They're both interior angles. They're inside of these 2 parallel lines, and if you cut through with the transversal, they're both on the same side. Now, I don't know if you remember, but these are called consecutive interior angles. And you can flip back in your notes now. So go ahead and pause the video and flip back in your notes, or maybe you can just look back in your notes and figure out what does it say about consecutive interior angles. It should say that they add up to 180. And so it's going to be like the X plus the 51 together equal 180. This one looks small, this one looks big, so they are not equal to each other. Okay, we can solve this for X. So we minus the 51, and we get X equals 129. And so we're done. It says solve for X using your knowledge of the angle relationships. We did that. Let's go to number 2. Take a look at number 2 and try to figure out, are these 2 angles, the X and the 94, are they equal or do they add up to something? If you're thinking they're equal, I think you're right. Those 2 angles, are they interior or exterior? I think they're exterior. And do you see how they're on alternate sides? So what we have here is we have alternate exterior angles. And if you look back at your notes, it's going to say alternate interior angle or alternate exterior angles are the same size. And so the X will equal 94. And that's all you have to know, is that those 2 angles will be the same size. Okay, take a look at number 3. What kind of angles are we dealing with? Well, to me, here's our 2 parallel lines. It looks like they're interiors. They're in between those 2 lines. And if we look at our transversal, isn't one on each side? One's on the left and one's on the right. So I think these are alternate interior angles. Alternate interior angles. And if you look back at your notes, it says something about their sizes. It should say, are they equal or do they add up to 180? Are they congruent? Yes, they are. And so, in other words, the 2x plus 1 should equal 105. Those 2 angles here and here will be the same size. So subtract your 1. 2x equals 104. Divide by 2. And x equals 52. Now this is not degrees, it's not the size of a whole angle, It's just the measure of x, or the value for x. Last page here. Take a look at number 4. What kind of angles are we working with in number 4? Well, one of them is interior, but one of them is not. So I don't think they're interior angles. I don't think they're exterior angles because they're not both exterior. So I think what we have here is probably corresponding angles. This angle and this angle, see how they're in similar spots? So these I would call corresponding angles. Okay, and what do we know if you look back in your notes? What does it say about corresponding angles? It should say that they are congruent, or the same size. So 3x minus 6 will equal the 81. Add 6. 3x equals 87. Divide by 3. And you might have to use your calculator for this. Let's see, 3 goes into 8 twice, 2 left over. I think it's 29, but check it for me. I did it in my head. Number 5. All right, will you pause the video and try number 5 on your own? Try to figure out what kind of angles are they, and are they equal to each other, or do they add up to 180? And then try to write your equation. So go ahead and pause the video. If you thought they are alternate interior angles, you're correct. And if you thought they are equal to each other or congruent, 8x minus 15 equals 5x plus 3, you are correct. They should be the same size. They both look acute to me. They both look little, and they are equal to each other. Minus 5x. So you have 3x minus 15 equals 3. Plus 15 to both sides. 3x equals 18. Divide by 3. X equals 6. Awesome. Okay, the last one is a little tricky just because of the way it's drawn. So what I sometimes like to do when I'm trying to figure out like what kind of angles are these is I'll extend the lines like this and the transversal cutting through like that. And then I can see a little better this angle and this angle right here. To me, they look like they're both inside. If I draw these in a little darker, they're both inside of those green lines. And if this is your transversal, they're both on the right. So I think those are not alternate interior, but they are consecutive interior angles. They are on the same side of the transversal. And so you can look back in your notes. What do you think? Are those the same size or not? Well, to me, this one looks acute, the one on the bottom, but this one up here looks bigger than 90 or obtuse. I don't think they're equal to each other. So what I think is they add up to 180, which 12x plus 4 plus 5x plus 6 equals 180. That's your equation. Okay, go ahead and solve this one. So pause the video, and when you're done, check your answer and see if you get the same thing I do. If you got x equals 10, yay, good job. So that wraps it up for Unit 2. Will you please try Unit 2, Practice 3, and if you have questions or get stuck, just send me a Schoology message. Have a great day.